All right, on note 7.2, we're going to get into graphing a rational function. So we'll be using what we talked about yesterday on horizontal and vertical asymptotes of a rational function. All right, so the steps for graphing a rational function with no holes. First step is always to factor all your parts. And then you're going to find your domain, which we talked about yesterday, which is whatever causes your denominator to be 0 will not be included in your domain. And then your vertical asymptote is that value that causes your denominator to be 0. Horizontal asymptote, remember we talked about you're checking the degree of the polynomial, which is the highest exponent of the top and the bottom, and then you're comparing them. From there you should be able to find your horizontal asymptote. The new stuff for today, you are finding the x-intercepts by setting your numerator equal to 0 and then solving for x. To find your y-intercepts, you're replacing x with 0 and then solving for y. And then the last step, you're going to graph the function. Okay, so example 1, first step is to factor everything. Notice we cannot factor negative 2x, so it stays as negative 2x on top. The denominator we can factor, that's difference of squares, so that's x plus 3 and x minus 3. Okay, so now we're going to find the domain. Remember, the domain of any rational function is all real numbers except what causes your denominator to be 0. So if you look at this first factor, negative 3 would cause that to be 0, so x cannot be negative 3 or positive 3. So domain all real except negative 3 and 3. Those two values are your two vertical asymptotes, so x equals negative 3 and positive 3. Your horizontal asymptote, you're checking the degree, which is your highest exponent. On top here we have just an x, so that exponent is 1, and then the highest degree on the bottom, our exponent is 2. So 1 is smaller than 2, which means your horizontal asymptote is y equals 0. X-intercept, if you look back up at the top of your instructions, or your steps, x-intercept, you're setting the numerator equal to 0 and you're solving for x. So if I set negative 2x equal to 0, solve for x, so divide by negative 2, and you get x equals 0. On your x and y-intercept, I want you to write those as ordered pairs. So your x-intercept is 0, and then your y will always be 0, because it's an x-intercept. To find your y-intercept, you're replacing every single x value with 0 on your function, and then you're solving for y. If you look back at your function, f of x is the same thing as y, so y equals negative 2 times 0 divided by 0 squared minus 9. You could either plug into your original or the factored form. It doesn't really matter. So you're going to get 0 on top. That's 0, so you're going to get negative 9 on bottom. So that would equal 0. So your x value of your y-intercept is always 0, and then we found the y-intercept to be 0. Okay, so now we're going to get into the actual graphing part. So we're going to graph our asymptotes, our intercepts. So the vertical asymptote we have at negative 3, so it crosses the x-axis at negative 3. And also positive 3. Alright, and then we have a horizontal asymptote at y equals 0, which is the x-axis. So make sure that you're able to see that horizontal asymptote. Alright, and then we have some x-intercept, or an x-intercept and a y-intercept. They're both the same. It's at 0, so at the origin. Okay, so when you have two vertical asymptotes, you're going to have three parts to your graph. You're going to have a part on this left side, the middle, and also the right side. So you're going to have three different parts. In order to figure out how they're approaching your asymptotes, you're going to plug in some test points. So start on the very far left side Notice our vertical asymptote's at -3, so -4 would be a good test point to figure out if it's going to be above that horizontal asymptote or below it. So whether it's going to be positive or negative, because we need to figure out, is it approaching it at the top or at the bottom? So I'm going to plug in a test -4. I'm going to plug it into either my original or factored form and figure out what y is going to equal. I really, on this one, all I care about is if it's positive or negative. So I need to know if it's above the x-axis or below the x-axis, which is your horizontal asymptote. So if we plug in a -4, so we're going to have -2 times a -4 on top over -4 squared minus 9. So we're going to end up getting a positive 8 on top, and then that's 16 minus 9, so that gives you a positive 7 on bottom. Okay, so overall it's positive. That's all we really care about on this one. Okay, so it's going to be positive. So in order for it to be positive, it would have to approach your horizontal above the x-axis and then curve back to approach that vertical asymptote. If it was a negative, it would be approaching at the bottom. Alright, so now we need to figure out from our intercept in the middle if it's approaching on the left side above the x-axis or below. In the middle, it will not be approaching the horizontal, only those two vertical asymptotes. So we're going to plug in, let's plug in a -1. So if we plug in a -1, we're going to get -2 times a -1 over -1 squared minus 9. So we're going to get a positive 2 on top over 1 minus 9, which will give you -8. So we're going to end up getting a negative, which means it will have to approach this way, that vertical or vertical asymptote. Now we need to look at the right side of that point. It's a 1. So I'm going to plug in a positive 1 into our original. So that's -2 times 1 over 1 squared minus 9. So we're going to get -2, and then you're going to get -8. So overall it's going to be positive. So in order for it to go from your x-intercept to positive values, when x is 1, your y is positive, it's going to have to approach that way. If it was negative, your y value negative when x was 1, then it would be an upside down parabola. So it opened down. Alright, and then we also have to look at this far right side. We're going to plug in a positive 4. So you're going to get -2 times 4 over 4 squared minus 9. So you're going to get -8, and that's going to be positive 7. So overall it's going to be negative. So when x is 4, your y is negative, which means in order to approach the horizontal and the vertical asymptote, it would be below that horizontal asymptote, which is below the x-axis. So if there's 2 vertical asymptotes, you should have 3 parts to your graph: left side, middle, and right side. If there's only 1 vertical asymptote, you'll only have 2 parts: left side, right side. Okay, let's look at example 2. First step, factor everything. So notice the top here, it's a trinomial. So sum is -1, product, make sure you look in front, that's -12. So that would be a -4 and a +3. You are going to divide by that 2 in front and use swing method. So that's going to be x minus 2 and then 2x plus 3. Now, the denominator, notice it looks a little different. instead of it being x squared minus 9, it's 9 minus x squared. So the negative part is the x squared. So it's not x plus 3, x minus 3, because that would give me a negative 9. So take the square root of 9, you can get 3 for your first terms, and then plus x minus x in order to get that minus x squared. Okay, so domain is all real numbers except what causes your denominator to be 0. So that would be negative 3, so x cannot equal negative 3, and then that would be positive 3. So those are the two x values that you cannot plug in because it would make it undefined. Vertical asymptotes are those two values, so x equals a negative 3 and a positive 3. Horizontal asymptote, you're looking for your degree, the highest exponent. If you look at the top, it's a 2. The bottom is also a 2. Those are equal. So remember, when they're equal, your horizontal is y equals a over b, which is the ratio of the leading coefficients. The coefficient of the top is a 2 over the coefficient of the bottom. The coefficient of the bottom is not 9. That's a constant. You need to look in front of your x squared. That's negative 1, which would make it y equals negative 2. Okay, so x-intercept, to find the x-intercept, if you look back at your steps, you are setting your numerator equal to 0 and solving for x. Now, I would say that you would want to use your factored, because we're setting x minus 2 equal to 0, but also 2x plus 3 equal to 0. So x would be 2 on the first one, so you're going to have two different ones, 2, 0, and then we'll subtract 3. And the other one is negative 3 over 2. If your top, your numerator, listen carefully, if your numerator is a constant, so for example, if we had 2 over x plus 1 as our original function, you would not have an x-intercept, because when you set that numerator equal to 0 and solve for x, there's not an x to solve for. So make sure that you remember that on your assignment. Okay, y-intercept. We're plugging in a 0 for every x and solving for y. Doesn't matter if you plug it into the factored or the original. So that's 0, we get negative 6 on top over 9, which reduces to negative 2/3. So your y-intercept, x is always 0, y-intercept's negative 2/3. Okay, so now we're going to graph our asymptotes. So vertical asymptotes are at negative 3. And positive 3. And then your horizontal is at y equals negative 2. Your x-intercept, we have two of them, 2, 0, and negative 3 over 2, which would be negative 1.5, so in between negative 1 and negative 2. The y-intercept is 0, negative 2/3. So really this one's a little less work on than the last one, because if you notice, you're going to have to connect those points. In order to approach those vertical lines, it's going to have to open up, because you have to go through those x-intercepts. So it's a parabola on this one in the middle. Alright, so really all we have to do is plug in a test point on the left side, so negative 4, and the right side, positive 4. All I care about is, now this one, our horizontal asymptote is at negative 2, not at 0. Okay, so we need to figure out, is it above that horizontal or is it below that horizontal asymptote? So let's plug in. We'll start with the negative 4. So we have 2 times negative 4 squared minus minus 6 over 9 minus negative 4 squared. Okay, so that's going to be negative 4 squared is 16 times 2. So that's 32. That will change to plus. So 32 plus 4 is 36. But then you have to subtract 6. So you're going to get 30 on the top. Do not change those subtractions on the bottom to plus because you have to square the negative 4 to get 16. So you get 9 minus 16, which will give you a negative 7. Okay, so 30 divided by negative 7, 7 will go into 30 4 times. So negative 4 point something would be our y value when we plugged in. Okay, so that means it's going to be below that horizontal because that horizontal is y equals negative 2. And we know it's going to be negative 4 for the y. So we know it would have to be below that horizontal asymptote and also have to approach that vertical asymptote. Okay, looking at the far right side, we have a 4. So we're going to have 2 times 4 squared minus 4 minus 6 over 9 minus 4 squared. So on top, that's 32, and these would be negative 10. So you should get 22 over negative 7. So that's going to be around a negative 3 point something. So again, that will be below that horizontal asymptote. Okay, so this is this is graphing a rational function by graphing your asymptotes and then your intercepts. And then you're having to plug in a test point to figure out where the graph is, either above that horizontal or below. And then same thing on the vertical.